All right, it is now day 2 of my own personal learning with Swift. So again, these are kind of prequel tutorials to the real tutorials I do one day once I've got this language figured out enough that I can actually teach something proper and really create an actual project. You guys know I like that. But here's where we left off. Yesterday I started a project called Day 1. Maybe I didn't have the most foresight when I created that project because it's now Day 2, but we'll leave it as Day 1. And this is what we did. We basically just got an image into our Sprite Kit scene here, and this is getting drawn from a class that is a subclass of SK Sprite node, and it's really not doing much else other than just putting that image on there. So let's extend this a little bit. One of the things I've always loved about Sprite Kit is that the physics engine is built right into it, as opposed to Cocos 2D. You kind of had to work with either Box 2D or a Chipmunk-based project, and I just never thought it was as integrated as smoothly as this. So let's begin. In our init statement, after what we've already put in here, what we can do is write self.physicsBody. You'll see that fills itself in for you. Always a good sign. And then we just put skPhysicsBody, and we're going to put in here just opening parentheses, and you'll probably see one of these suggestions over here because I've already been using rectangle of size. I believe that's why it's auto-filling in that one for me. And we'll go with that. So rectangle size, and sure enough, we've already got a nice little size that we can use, which is that of the image texture. So our physics body is going to be exactly the same as the texture itself. And of course, that's something you can change later on. You could create your own CG size a variable to base it off of that image, but maybe multiply down a little bit, do a fraction of that size. But for right now, this will work for us. And then we're going to just write self.physicsBody. And well, you know what? I noticed that if I tried, let's see, to do something without that question mark, it filled it in for me. So there we go. It wants that to be apparently optional. And then I'm going to set it to being dynamic, set to true. If I had this set to false when we added this our body or our object to the scene, it would just stay there. But if we set it to dynamic, that means that things like gravity, physics are going to be pushing and pulling on it. So you'll actually get to kind of see the physics working is the point. And then if you just want to, go ahead and check out some of what the other options are here. If you just put in physicsBody dot, and this is one of my favorite ways of just kind of navigating through and seeing what else is possible. You could set the density. I'm going to just type an M here. Mass is one of those other ones. So what the heck, why not? We'll just set it to 1. And now let's scoot back over here to our game scene. One of the things I'm going to do is just going to put this little destroyer guy up a bit, okay, because at 200 he's going to be sort of bordering on the bottom of the scene, and we want to see him fall down as soon as he gets created. So there you go. That's what you get. Did you miss it? He's not coming back. I have to build it again. There it is. So he's gone. Let's do this. Let's go back to our destroyer class, and we will set this to false. And yes, like many of you Objective-C programmers out there, I keep wanting to write no. But now it's false, okay, which probably is a change for the better. And now what we'll do is we'll move around our destroyer object based on the touch, and then we'll also force it to be dynamic. So let's do this. We'll just put in here. Actually, I'm sorry. Let's go back over here. We'll put in the function first to set this to be dynamic. So we're going to put in here make body dynamic. That's what I'm going to call this function. And as many of you know, this is, and again, I keep wanting to say method. This is a method or a function that we can call as needed. And the nice thing is, here in Swift, you don't have to make any sort of public declaration that other classes can call this function. And I think that's actually a really nice change. Previously you'd have to go over to your header file and then, like do something like this. blah, blah, blah. This is the header up here. And it's kind of just saying that, hey, you know what, other classes can call that. And, in some ways I think that this Swift language is trusting us to have our functions accessible like this. So now we're just going to write self dot, we can just copy out our code right here. So, and of course you could do anything here aside from just making it dynamic. You could access any of your other physics properties to change those at runtime whenever you call this. So if you wanted the mass to be 100 now, you could do that as well. We'll be happy by just making this dynamic. So that's all we have to do. Now we can jump back over here to our game scene. And let's start by setting the position inside of our little touch statement here. So anytime we touch, we're going to take our destroyer node, and one of the things I noticed is that above I had that forced unwrapping. Basically, we're forcibly asking for a value from our destroyer node, and that was necessary for the add child. But turns out you can just go with that question mark here as well, and I can imagine the reasons, but I'm sure I'll know the reasons a lot better later on. So anyway, we've set that position value, and of course now we still haven't made it dynamic when we push down, but now you can see that our little guy is moving around on the stage. Let's think about this for a second. What if we wrote if and then destroyer node does not equal nil? How about that? And then put everything inside of here. Now I would imagine that it makes a little bit more sense to put your exclamation point right there, because we know that this has a value. All right, so this is essentially saying, well, this may or may not be nil. All right, but let's test it. Okay, so if that does not equal nil, well, then we can do everything inside of here, and then we can throw in an else statement that says something like print. Let's just write. That destroyer was not really there. How about that? So then if you had a situation like where you had not actually added this, let's take away adding our destroyer node. We would run into this. Well, we don't see anything, so we tap down here and it says that destroyer was not really there. Now that's not something that's particularly Swift-centric. We could have tested for an object being nil in the past, but I guess we'll go with this anyway. I mean, why not? So destroyer node. Now this time around, let's go and let's set the physics body to equaling true, and then let's run it again. And you know what? I'm sorry, I missed one thing here. Set our physics body's dynamic property to being true, and let's give it a shot. Okay, now you can see he just kind of drops away, and he does it really fast, and I sort of wonder if maybe when we move him around like this, he's keeping some of his velocity from before. And there's another thing I got to quit doing is I have to stop hitting Apple Q whenever I want to quit the simulator, because it always throws up an error and then just puts me in some awkward screen. I had this idea that I don't think it actually did much, but I'll throw it in here anyway. Was to put in set the velocity to something. We'll set it back actually to 0, and I might be on the right track right there, but I didn't actually notice a huge difference when I tested this. But there you go, a little. Well, actually, it does seem to slow it down a bit. Yeah, that's way less fast than it was previously. Okay, so that does work, and I will delicately put that. That build behind this screen instead of quitting, and let's finesse this even further. One of the things we could do is instead of immediately doing these things, is go and wait a little bit. So we'll create an action here, and this will be a new SK action. And one of my favorite ones, my most used ones, oddly enough, is to just wait. All right, I do this all the time in my iOS starter kit. Is we just wait for a duration, and so we just put in here SK action, wait for duration. Let's wait 2 seconds, and then we will come over here, write destroyer node run action, and that's just going to be the action name there, wait action. And I'm going to put a completion in here. Notice, by the way, too, it did help me out and put in that little question mark. Since we are testing this, might as well just switch it to an exclamation point. And then so a completion, and this is going to be a block of code that runs after things have actually completed. And let me go ahead and just fill this in correctly if I can. Okay, well, what didn't you like about this? Oh, probably that I forgot the semicolon or colon. Okay, and what don't you like over here? Oh. No, I think, there you go. So used to those semicolons. All right, now, so what we do inside of here will occur after this 2-second wait. All right, and believe me, that is very useful in game programming. You can imagine all sorts of situations where you just want something to happen and you want to wait a little bit. Okay, so what we'll do is we'll call a function, and I'm gonna name this function as some event. All right, so just whatever it is, some event. And I believe you do have to put the self in there because it didn't like it without that. Well, the error that's complaining about right now is that game scene does not have a member named some event. Odd that I would call it a member. But now we're going to come down here and write that member. So it's going to be func some event, and we're not going to pass anything into this this function, okay, and we're not going to ask for anything out of it. All right, so it's just going to essentially execute the code that is inside of here. Really not that much different than if we had just written it over here, but just for the purposes of kind of testing things out, playing around, I thought I would peel out this function and put it down here. So really, you know, we don't even have to do that much. I mean, we could just put in here a log statement or print something out, and we could just write the wait is up. But what we'll do is we'll take this same destroyer node again, and this time we'll set it to true here, and we'll put it to false, or false, if I could type right, over here. And I'm about to forget, actually, that we were going to call a method inside of our destroyer node, which is this make body dynamic, to tie everything back together. So no, actually what we want to do is now write make body dynamic, and let's take a look at our final product here. Shall wait a little bit. There it is. The weight is up, and sure enough, it is becoming dynamic again. So the big thing I think to take from that is that again, we did not have to declare this function anywhere else. It was open and available to our main game scene class. We just had to type in here destroyer node, followed by either that question mark or that exclamation point, and then dot, and there is the function name. So obviously something to play around with in the future coming up will be to actually pass in some parameters or return some values from some of our functions. These are relatively simple functions. Anytime you just see these opening and closing parentheses, right, it means after each other means that there's really not that much going on with it. So, and again, you could have probably just gotten away with writing that right there. I don't see that we would get a okay, right, okay, but yeah, I'm gonna leave things as they were because that was working nicely and kind of proving my point. So anyway, that's it for day two's little adventure here with Sprite Kit and Swift.